business decisions from that data sets. And when we look at a traditional data warehouse, we look at what are some of the challenges in the technology today that are stopping us from meeting some of those analytic goals. And if you take a traditional data warehouse, we can really separate it into three components. At the top layer, you have your BI and analytics, and where you do your general decision making from the reporting of the data sets. In the middle area, you have your data management and data enrichment. And you also have your infrastructure and box. And so with these three components, you look at how can we develop a traditional data warehouse and kind of evolve that technology to meet some of the challenges in these three areas. And when we talk to customers, we see that the general challenges in these three areas are the following. So from the BI and analytics perspective, we see that taking traditional data warehouse and trying to deliver high-speed analytics or high-performance reporting is becoming more and more difficult with the types of business questions and the types of speed that our customers are looking for, sometimes in the second range. We also see that a lot of the business users of these data sets are now asking for self-service and ad hoc, so they don't want the IT teams to go in and try to understand the questions that business is going to ask and create indexes on those structures. They want to be able to expose those data sets to all of the business users and let them ask any question of that data. And the third is when you expose that data and you also have a requirement to have high speed, it really becomes complex analytic data sets that you don't see a traditional transactional engine is really optimized for doing. Now, if you take that a step lower and you look at the data management and data enrichment here, you see that a lot of the customers are now having huge growing data sets that they can't really incorporate into their data warehouse. A lot of customers that we go to are purging data sets. They only keep a couple of years of historical information on those systems, and they have a really tough time with having all of the data in one place. And it's not just the data, it's also the variety of data. So this is where you start to think about the big data piece, but what we're really talking about here is data sets that aren't modeled or data sets that are difficult to put a schema on quickly. And so they aren't easily put into a data warehouse. So where do you put that type of data and still get value or insight out of it? And the third is we're seeing a movement towards the near real-time aspect of the data warehouse. So how can we get data in at a more near real time, such as every hour or every 5 minutes? And so taking these 6 areas and looking at the traditional challenges we see from the infrastructure or the architecture perspective, what's the box that this data warehouse is running on, we see that a lot of our customers are moving to duplicated systems. So when you hit a wall with your SQL Server SMP architecture and you can't really scale that out and bring general or extra performance to the system, you start having duplicated systems. And so new projects slide to new hardware, to new databases or data warehouses. A lot of times we see complex architectures, so you have data duplicated across your organization, data movement across the organization, and it really lends itself to an inadequate design. So when you talk about the latency of that data and exposing it for reporting, it becomes very difficult in your overall architecture. And so when we looked at these 9 areas and we looked at how can we take SQL Server and evolve it to an analytic or a data warehousing mindset so that we can address all of these areas, we took the SQL Server technology and we built PDW on top of it to deliver on these key items. So let's talk about that. We built PDW to address those 3 areas, and we deployed 3 key technologies in PDW to do that. So when we look at the system, from the high performance or analytics perspective, we deploy SQL Server on an MPP architecture. And so that's what we mean when we talk about parallel data warehouse. We don't know what MPP stands for. That's massively parallel processing, but it's essentially using multiple physical servers and virtualizing them as one, so that when you run a query on your system, you're actually running that single query across many servers. And this is done automatically by the MPP architecture system. The second area around the data management and data enrichment was around how do we deploy a data warehouse that can deliver insights on all data. And so we do that within PDW with a key technology known as Polybase. Polybase allows us to take the T-SQL query engine, the cost-based optimizer of that engine, and deploy it to Hadoop systems. So what you'll see is that we're actually taking SQL queries from business users, and it doesn't matter if that data is in Hadoop or if that data is in the database in PDW. We'll actually use the query engine to go after that data and where it resides, and we'll actually run code where that data resides as well. And I'll show you a little bit later how we do that. The third area is around the low cost and rapid value. So when we talk about the architecture, we didn't want to have our customers having to spend a lot of cycles, a lot of time and cost figuring out what's the best architecture for each data warehouse they're going to deploy. And so we spent a lot of our research and development up front to say, how do we deliver a system that's low cost and rapid value? And we do that with PDW by delivering as an appliance. So we've partnered with the leading hardware vendors in terms of getting the system's physical architecture, and we deploy that very tightly with our software architecture, and we'll show you how we do that a little bit later. So if you look at these three components a little bit further, let's look at that high performance and analytics piece. We talked about MPP. It allows us to scale out our system and run queries across multiple servers automatically. We're actually running PDW on SQL Server's engine. So we're using the same cost-based optimizer and the mature engine that we have in SQL Server, but we've now extended that to a parallel architecture. You also see that we deliver the system as appliance. We don't have a reliance on high-cost SAN. We actually have direct attached storage. It's high speed, and it allows us to have just the right amount of I/O bandwidth for each one of our servers in the system. So we're tightly coupling the processing power of each server with the I/O with the disk power of the system to get that linear scalability in this platform. The second is around insight on all data. So we'll talk about how Polybase allows us to extend the T-SQL query engine into big data systems or Hadoop systems. We've also done some innovations in terms of the cluster column store indexes. We were actually one of the ones to take the SQL Server technology and pioneer some of the updatable CCI, if you're familiar with what's coming out in 2014. From the engineering group in PDW, we actually took that as a requirement for the near real-time access. And so we deployed that first in PDW to allow our customers to be able to load data and query it in real time. And the third is around we deploy NPP architecture as a shared nothing in PDW. So when we say shared nothing, none of the servers, none of the storage is shared across the system. And so that's what allows us to scale linearly. As our customers add twice the amount of horsepower to the system, they'll expect that they get all of their queries to run in half the time. From the low cost and rapid value perspective, again, we deliver the system as appliance. We want our customers to be focusing on bringing the data sets and exposing them to their business users, not focusing on re-engineering systems or re-engineering data warehouses. We also partner with HP, Dell, and Quanta in terms of the system, so we're not looking at deploying any specialized or different types of specialized CPU units or components within the system. We're running on all standard hardware. And you also see that we use automatic compression within the PDW system. So whether you store your data sets as the row store or you store it in the column store technology, you're going to get high compression. With the columnar technology, you're going to get about 5 to 15x on the data. And we typically see a customer storing about 80 to 90% of their data as columnar in the system because they're really using this for analytic workloads. So now let's take a step a little bit into the three areas that we talked about that PDW delivers. And once we get through there, I'll go into a deep detail of how PDW works and the actual technology underneath it. So one of the key areas we deploy in the SQL Server family is this ability to scale. And so what you'll see with PDW, whether you're going with HP, Dell, or Quanta, is the high performance of any size. And so our customers are able to start off within that single rack footprint. We start off with a quarter of a rack from HP or a third of a rack from Dell or Quanta. And from that footprint, you have the opportunity to grow as you need. So we don't have this concept of ripping or replacing your system or having to go out to new systems, different SMP architectures. You can add capacity to your system as you grow, both from a storage perspective or if you need more performance in the system as well. And so you can continue adding capacity to that single rack system as you start out, or if you have a greater requirement in terms of your data set, you can start off with a bigger footprint, all the way up to 6 petabytes. So you'll see that we have many customers on the PDW system starting at all different ranges. Generally, you're going to see them, 1 terabyte, 5 terabyte if they have very complex analytics. And then as you move along the scale, it depends on the combination of those analytic requirements, the business requirements for speed, as well as the amount of data that you're storing. Let's talk about that ability to have insight on all of the data. So we touched a little bit upon Polybase and what we do within the general architecture of extending the T-SQL engine, but our real goal was to expose the data. So just how we talked about exposing your structured data within the database in PDW to all of your users and not having to have multiple or different indexes on the data, you just store it all as columnar and you have the speed. We wanted to be able to expose that Hadoop data as well. And so when we talk about extending the Polybase engine, we do that with directly interfacing with the Hadoop API. And so what we typically see is our customers are now being able to use PDW as their analytic gateway to all of the data sets you have across your organization. You can connect all of your Microsoft BI tools directly to PDW because it exposes itself as a SQL Server engine. And we have different components that we integrate with in the big data space. So the first thing you'll see is that we spend a lot of our research and development in building a very tight integration with the Hadoop systems. We're actually doing parallel bulk data transfers into and out of Hadoop. So whether you write a query that pulls data in from Hadoop or you write a query that pushes data out to Hadoop, you have the ability to do that at scale. So whether you have 2 Hadoop nodes in your cluster, or you have 64 of them, or 100 or 128, we'll actually scale out the system to take advantage of all of those nodes. We also access the Hadoop files from an extraction layer. So we're actually showing Hadoop files or Hadoop directories as external tables in PDW. And so when a user queries data within the PDW engine, they don't really know if that data is coming from Hadoop or if that data is coming from PDW. The third area is we wanted to make sure that the technology is open. We see that there is a lot of different distributions in the big data space. There's a lot of folks that are looking to bring different analytic capabilities to these new unstructured or non-relational data sets. And so we want to make sure that Polybase could integrate with the Microsoft family very well, but also all the technologies in the big data space well. So you'll see that we're certified with Cloudera and Hortonworks. Whether you're running the Hadoop system on Windows or you're running it on Linux, we'll still integrate Polybase with those systems. The third area around the appliance aspect has 2 real drivers to it. So when we talk about designing that software and hardware together, number one, we want to be able to deliver that overall solution at a low cost. And we do that by, number one, taking advantage of the different Microsoft technologies we have. For example, we use Windows Server 2012 storage spaces to deliver RAID 1 high availability on JBOD disk architecture, direct attached disks. So we've moved away from the high-cost SANs. We don't have to have a high cost in terms of expensive disk array controllers. And with that system, we're able to bring the high availability you see in these types of data warehouse solutions. We're also taking advantage of Hyper-V virtualization, so you'll see that a little bit later we'll show that we can break every component in the PDW system and they'll still come back online and be running. And so what we've done is not only brought the high availability at a lower cost for the overall solution, but another thing you'll see is that when we go over the technical architecture, we've actually made design choices in terms of how we distribute the data and how we actually run the queries so that we're taking advantage of the hardware underneath and we're making sure we're getting the most performance out of the system. So with that, you have an idea of PDW, why Microsoft created it. You have a general idea of the 3 key components or the technologies that we're deploying in the system to enable us to meet all those customer requirements that we discussed. So now let's dig a little bit deeper into the technology and look at the actual architecture, what's running underneath. We'll look at some scenarios of what happens if you run queries on PDW. And what you'll start to see, sometimes I'll get asked questions is, well, what's the difference between PDW and a SQL Server? Well, if I run SQL Server on a very massive system, DL980 from HP, and what you'll see is that because we've tightly integrated these components, and that the fact that we deploy these key technologies in PDW, we've really extended the SQL Server family now to meet all of the analytic needs we see for our customers in the data warehousing space. So the first component we're going to look at is the PDW logical architecture. And when we talk about the logical architecture of PDW, the first thing we want to look at is the control server. Now, the control server is also known as the brains of the operation. The control server is where we actually take our queries, we have all our smarts about the parallel architecture, and we say, how do we take a query from a business user and run it in a parallel fashion? We also do things like, how do we take a data load and spread that data across the system based on the distribution key that we've defined? And so the control server is where we take the queries from the users in the system. So when a user comes into PDW, it doesn't matter if the PDW system is 2 nodes or 20 nodes, the user is going to interact with PDW just like a database, like any SQL server. They log into the system and they run their query. When the user runs their query, there's a couple of steps that have to actually run that query across the parallel system. The user submits their query, and the following steps happen. So we first see that the user submits their query to the control server, and the control server is where the optimizer lives. The optimizer is parallel aware. It takes the user query, it looks at the parallel architecture, and it looks at how the data is spread, and it defines a low cost, or the lowest cost, query plan to run that query across the parallel system. Now, the other component of PDW that's very important from the logical architecture is the compute servers you see here at the bottom. So the compute servers are also known as the brawn. And we call it the brawn because the compute servers is where the actual queries get processed. So for the folks that are familiar with Big Data or Hadoop, you might see a resemblance of some of the Hadoop architecture in terms of how the PDW systems deploy. And so these are the MPP architectures we talk about for running parallel queries or parallel processing. And so what happens in the logical architecture is when the user runs their query, the control server optimizes it and runs a parallel query plan, and then the control server sends a parallel query down to each one of the compute servers. Each one of those parallel queries is just a portion of the overall query. It runs on each one of the compute servers, just solving its portion. The data is combined, and it's sent back to the user. Now, there's components within the PDW architecture that's making all of this happen. So what we have is in the control server, you're going to find 3 key areas. Number one is we talked about that optimizer, and this is the real brains, right? This is where we put a lot of research into how do we take a query and run it efficiently in a parallel system. We also have metadata and statistics. So for the tables that we bring into the system, we want to understand what is the metadata of those tables, what do they look like in overall structure, and what's the demographics or the statistics about that data, so we can get an understanding of how it's spread across, and also when we process our query, what's the best way to process that query given the data. The third area, and this is really the key for the PDW architecture, is the data movement services. So what we looked at is the most efficient way to run a query in a parallel architecture is going to require you to move data, especially when you're looking at relational type processing and you're joining data across different data sets. Your ability to move data efficiently across the system is going to lend itself to the lowest cost plan within a MPP architecture. And so what you'll see in the system is that data movement services is responsible for not only sending the system into, send the query across the parallel system, but it's also running all of the data sets automatically across the servers. So you'll see that when we look at the next section, when you load data, you're actually able to load data automatically across the servers using the data movement services. So let's look at an example of data distribution when we create the fact sales table here. This is an example of a typical table we see for many of our customers. You have your fact sales table, you have each of the different data types, and you have what those column names are. So it's your typical DDL for SQL Server. However, the big difference you're going to see between SQL Server and PDW is that for each table you define within PDW, you have to define the distribution key. And I'm getting IM, so let me turn this off. Sorry, guys. So as I was saying, you're going to get a different distribution key that you define for each of your tables. Now, this is a logical construct that we use to distribute your data across the many servers on our system. And what you're going to want to define is a distribution key that has a good cardinality in terms of your number of rows. So if you think about a typical table, you don't want to use a distribution key that's one or two different values. You want to use a distribution key that has a good uniqueness, like an ID key or some other key that's used. Here we use the product key. But you will see that we have the different constructs in a typical SQL Server, like the clustered index and partitioning, so those don't go away. And let's talk a little bit about that difference between the distribution and partitions. So when we create a table within PDW, you're going to have the user come into the system, and as they did before in the logical architecture, they're going to submit a query. Right? They're going to submit a DDL statement this time to the control node. And so the user comes into the system, and they run a query against the control node to say, let's create this fact sales table. And they create the fact sales table against the control node, and a series of steps happen. So let's say in this example we have a compute node 1, compute node 2, all the way up to compute node 10. So in the example we have 10 different compute nodes and 1 control node. And so the user comes in and says, let's create this fact sales table. Sends it to the control node, and the first thing the control node is going to do is going to say, all right, let's create the metadata about the control node, about this table, and let's store it on the control node. Once the control node does that, it's going to issue a set of create table statements to each of the compute nodes. If you think about taking this fact sales table and spreading it across these 10 compute nodes, then you would think intuitively that the control node is going to create one fact sales statement for each of the compute nodes. And so in general, if we have 10 compute nodes, the control node should issue 10 create fact sales statements, right? One for each compute node, which we have 10 of. But what we're actually doing is a little bit more than that. So what happens on the PDW system is that when a user issues just a single create table statement, we're going to issue a create table statement to each of the compute nodes, but we're going to create 8 different distributions on each of the compute nodes. Okay? So if you think about this user coming in reading the table, they create a single table, and then the control node issues 80 fact sales create table statements. This is 8 different fact sales statements per compute node, and if we have 10 compute nodes, that's 80 different statements. Now we do that importantly because of wanting to tightly engineer the software architecture with the hardware architecture. If you remember when we talked about the appliance, we're not only doing that for the low cost so we can see what's the best way we can deliver high availability on the lowest cost hardware solution, but we're looking at what's the hardware architecture underneath, what's the number of CPU cores, what's the number of spindles, and how many different table distributions do we create on each of these compute nodes to drive the most performance, even if we're querying a single table. And so I want everyone to be clear that there's one portion in this fact sales statement that we intentionally left out. And if you notice, there isn't the on keyword. So when we talk about data placement doesn't exist in the PDW system. You're not going to have to understand the file groups or the number of LUNs or the spindles or anything to do with the data placement or the disks. Because what we do is based on that logical construct or this logical identifier that you define, we're going to distribute the data across the system. And we're going to do that automatically. So even when a user creates a table or they query one of the fact sales tables, they have no idea that there's these 10 compute nodes and that there's 8 distributions per compute node. Now, when I talk about distribution, I want to be clear. These distributions are essentially holding a portion of the fact sales table. And so if I take a very simple example, again, I'll remind you that we have 10 compute nodes and 8 fact sales distributions per compute node, meaning we have 80 fact sales distributions. Now, if I take a simple example and I say I have this fact sales table here, and it has 160 rows, if we choose a perfect or very good distribution key, then you're only going to get 2 of those rows to each of these fact sales tables, or these fact sales distributions. And so this data automatically distributes across all of these distributions automatically. And keep in mind, when we run a query, we're actually running a query against each of these distributions. So if a user comes in and they do a select star against a fact sales table, what we're actually running is 80 queries under the covers. We're running 80 queries, each against 1/80th of the data, because it's determined by the number of fact sales distributions that we have. Finally, I wanted to bring up partitioning. So partitioning doesn't go away. If you think about using partitioning in terms of administering the system, being able to load an empty partition outside of your core tables and switching that partition into your table, you still have those same capabilities to deliver some of the near real time that you're going to want to do on the system. And the other component you'll see about the PDW system is that we maintain all of your partitions automatically. So it doesn't matter the number of compute nodes you have, the number of fact sales distributions you have, or the partitioning scheme that you come up with. All of this is maintained automatically by that data movement services we talked about being one of the key components of the PDW system. Okay, let's take some big data examples now. You guys have a good understanding of PDW. You understand the logical architecture, how it's a little bit different than SQL Server. It's now taking SQL Server and extending it to the parallel or the MPP type of architectures. And what we typically see for our customers from the Hadoop space is that we're using Polybase to extend our data sets to the Hadoop environments. So when we talked about, we spent a lot of our R&D in terms of integrating natively with big data. We're using the HDFS API to push and pull data. And based on your T-SQL query, we're actually running MapReduce under the covers against the Hadoop environment. So what we've essentially done is taken away the complexity of having to write some of the code to expose the data sets in Hadoop. So what we typically see in the big data space is the following architecture for using the big data for analytic purposes. You'll see Hadoop is the data lake. It's positioned as the place where you can store all of your data. If you know about HDFS, it's a distributed file system, and so you don't have to understand what your data looks like, put a schema on top of it to get it into the system like you do with a database. You can just land the file into Hadoop and it'll get distributed automatically. And so it's called the data lake because we see a lot of our customers putting these data sets they don't know what to do with directly into Hadoop, being able to store it online at a low cost, and being able to process it when they need to. This can load the data into the Hadoop data set in the day, the hour, the minute refresh cycle. And where we see the PDW system is, it's really positioned as the analytic gateway to the Hadoop or big data platforms. So the PDW system is really used from an analytic mindset in 2 ways. It's used to do analytics, ad hoc, and visualization directly for users engaging with the PDW system. And it's used to expose the T-SQL interface to a lot of the Microsoft BI tools and third-party BI tools that we see. Now, whether the data is in PDW or the data is in Hadoop, because we expose Hadoop data files and Hadoop data directories as external tables in PDW, we can expose that data through the system and process it where it lies. So let's take an example of how we actually do that. Here we're going to look at what the MapReduce pushdown, or what we call PREDICATE pushdown, actually does on the PDW system. And what we see is typical big data user query. So they're looking at Twitter data. They want to know the user, the product, and the social sentiment of that data. They're querying what's called the Twitter table, which is actually an external table that is data in Hadoop. And we see that they have some criteria on the data. So they want it to be in the last hour, and the date equals today. and the social sentiment is less than 0. So typically what you see on Hadoop systems taking that unstructured data from Twitter and putting some structure analysis on it is they'll do sentiment analysis on the Hadoop systems. They'll take a user's tweet and they'll put some positive or negative sentiment on it based on the words they use. So if they use positive words, it gets a positive score. If they're using negative words about a product or a marketing campaign you have, you get a negative score for that tweet. And so what you see on the Hadoop system is we'll take massive amounts of that Twitter data and it will aggregate on it, it will do the sentiment analysis, and it will store the structured data sets that you can query against and you can expose to your business users. So you see here within a Hadoop system, either an HDFS file or directory, we can point our Twitter table that actually has schema under the covers that's pointing to these HDFS paths. And when it points to this data, we see that we can actually use this data from the user's query in the following fashion. So a user runs a query against PDW, and that user's query does the following things. PDW takes the user's query, and number one, it recognizes that this Twitter table is actually pointing to an HDFS file or directory, and so it does dynamic binding. It looks at that Twitter file or the directory, and it says what kind of data is in there, and how am I going to affect my query plan based on the Hadoop data. The next step that you're going to see is that the T-SQL engine in Polybase looks at what are the select criteria. So are we selecting all of the columns in this Hadoop file, or are we only selecting portions of them? And so what you see is 3 different selections in our system. We have user, product, and sentiment. And when we look at the Hadoop file, we see that we actually have multiple columns in the Hadoop file. And so the Polybase engine will say, I'll create a MapReduce job, and more specifically a map job to say, I only want 3 of those columns within my query to come back. And so that MapReduce job is actually going to run in Hadoop based on this user's query, and so I'm going to filter out the columns we need. The next step is Polybase is going to look at the where criteria and say we're querying data in Hadoop, and we only want a portion of that data from a where criteria data set that's going to be only a portion of the rows. And so we do some row filtering. And we say, well, we're only looking at the last hour, and the current day is today. And so we say, okay, how do we filter out that data? And we run a MapReduce job to make sure that we filter out just a portion of that data. And in fact, all of these different filterings are combined into a single MapReduce job to filter out the data that we need. Finally, we see that who has a low sentiment score. We see that maybe Sean or Suzanne had a bad experience. It could be with the Xbox product here. And we see that their sentiment was negative or neutral, and so we might want to see what was going on. But essentially what we're saying now is that we have a near real-time access to Hadoop data. Because we're doing that dynamic binding, it doesn't matter when that data lands in Hadoop. It's at the time of the query that we check the data is there and we're able to query it. And then we're also actually doing MapReduce jobs based on the query to do row filtering and column filtering. Okay, so we talked about the logical architecture, we talked about the integration with PDW, so we should have a good understanding now of how PDW extends the relational world into an MPP architecture, and now how PDW is using these big data technologies to expose those data sets as they are to business users. The third area I want to go quickly across is the physical architecture. So we talked about the system being an appliance, and we really looked at what's the best physical architecture for deploying this data warehouse solution. And we really broke that out into 3 components. So number 1 is your control and your compute host. These are your standard one-use servers. Then we talked about Hyper-V virtualization, your dual socket 16 core and 256 gigabytes of RAM. We have dual redundant internal networks. We use InfiniBand 56 gigabits per second to do our data movement. We also have 10 gig and 1 gig Ethernet to do the control management framework, as well as connecting into your network in the data center if you don't have InfiniBand. I/O subsystem. So we talked about the direct attached storage. We're using storage spaces for the RAID 1 mirroring. We're using dual SAS 6 gigabit per second connections, and you have the option of 1, 2, or 3 terabyte hard disk drives for the system. What you also see is that we've chosen the right number of spindles or hard disk drives for each one of the systems. So you have 66 disks for each one of the 2 compute nodes. And we have hot spare drives. If one of those disks in array 1 pairs goes down, you can actually run on the hot spare. It'll get recreated, that data there, so that you're online and running with another pair. So if we take all these components and kind of stack it in the PDW footprint, you'll see that you have to start with a single rack. That's your single box or entry point to PDW. And you'll have your InfiniBand network, Ethernet network, and your control host and failover host that has your virtual machines that you're running on the system. The failover host takes over for any of the hosts that go down, either compute server, control server. Since we're using Hyper-V, you can migrate over to that failover host. You also have your compute host, and this is your direct attached storage along with that. So this is what we call a quarter rack from HP. It's a third of a rack from Dell, which would have just one more server and some more storage. And you can grow this out as you need. You can continue adding servers to the system until you grow that out to a full rack, and then you can start growing into multiple racks as you have continued processing requirements and storage requirements. We're introducing also with our next AU1 update, which is our next software release for PDW, we're going to allow you to also upgrade with HD Insider. It's our Hadoop on Windows. It's a Hortonworks data platforms on Windows. Microsoft's version of Hadoop, which is HD Insight. And so when you go with that base entry-level footprint into PDW with your network control and compute host system, you have the option to grow out. So we talked about adding those additional servers and storage to make your PDW system bigger. You also have the option to add what we call a Hadoop base region. And so that'll come with your Hadoop name node. We have the failover host, so we have the secondary name node that we can run within failure within the name node. And then we have our data nodes across each one of these compute hosts. Once that happens and you have a Hadoop base region and PDW base region, you have the option as you grow out the system to grow a PDW scale unit or a Hadoop scale unit. So really, depending on where your requirements lie, both in the Hadoop area or within the PDW area in the relational world, we make it very easy for you to grow out the system and meet whatever requirement you need from your users. Quickly, we'll go over the single point of failure. So if a disk goes down, we have the RAID 1 mirroring. If the JBOD goes down, we have mirroring across the JBODs. If a compute host goes down, that compute VM automatically migrates to the failover host. If one of the networks go down, we have dual redundant networks. If InfiniBand, of course, goes down, we have dual redundant. And again, with the control host, that fails over automatically to the failover host. So you see in the PDW system, the way we've architected, there's no single point of failure. And if you draw a big X across this thing, you can also do disaster recovery systems. You have geographically separate instances of the PDW system. Looking at the mixed workload, so we have different ways of loading PDW. You talked about Polybase. We have a batch load utility to load near real-time to PDW. And we also have through SSIS a PDW destination adapter. Typically, you see ELT type solutions on PDW, taking it from staging area in PDW to the core reporting tables. And we have our customers using multiple different analytic tools against the PDW system. So we have a create remote table command within PDW. You can actually do your processing in PDW and send the results out to SQL Server spokes. We have a lot of our customers using PDW in the real-time access or near real-time access sense to do rollup through their analytic workloads in SSIS. They can also do tabular direct query against the system and expose either data in PDW in real time or data that's exposed in Hadoop through Polybase. We also use the native access client to the PDW system, so if you're using some of the third-party tools like OGA SQL Server, tools like Business Objects or MicroStrategy, we have customers using that as well against the data warehouse. One thing I wanted to show in terms of our roadmap is that when we look at PDW, we've actually chosen to take an aggressive roadmap in terms of continually delivering performance in the system. So if you remember, we talked about our overall approach is we wanted to deliver performance through the software architecture and run it on your standard hardware from your leading vendors like HP and Dell and Quanta. So what we saw is that we can continually add performance, new features, and functionalities into the system on your existing footprint. And what you'll see is that we're a little bit more aggressive than some of the other tools in the Microsoft family in terms of delivering those feature sets. So if you kind of think of Service Packs, it's a little bit like that. Within the PDW system, we're delivering what's called appliance updates. And so if you choose, when these appliance updates are released, you would go in and with our PDW engineering support, we'd go and do the software upgrade to the system, and it would enable new capabilities. But some of the Polybase features you saw, being able to extend those T-SQL queries out to Hadoop systems and run MapReduce automatically, those are some of the feature sets that we deliver for our customers using PDW today. So depending on when you look at PDW, you always have the ability to grow into the system and make those different feature sets come in without having any disruption from moving to a different technology or a massive upgrade. One of the last areas that we wanted to talk about is in terms of how PDW fits in the overall end-to-end solution. And so when we look at PDW, we'll take an example of the Microsoft stack. We certainly have many different data management and information management tools in our family. And so if you look at a customer using those tools from an end-to-end solution perspective, we see the following in terms of the different spaces. So on your left, you really have your big data sources, and these are social data, it could be device data, sensor data, etc. So your more unstructured or non-relational data. And these are coming in through the cloud or coming into your on-site Hadoop cluster, either Hortonworks or Cloudera. And what we see within those is that you can load data directly into Hadoop. You don't have to model it. Once you get some structure and value and insight out of that data, you can expose it through the SQL Server PDW system. PDW also has the ability to extend Polybase out to Azure. So if you're using some data within the Azure Storage Vault, we're going to have the ability to extend Polybase to data sets within Azure. As you also saw, we have the HD Insight within the PDW system, so you can have all of your unstructured and structured data within the PDW footprint as well. We have Stream Insight for your complex event processing, so if you're getting Twitter data on the fly, we can do our sentiment analysis against that data using Stream Insight, and we can have real-time alerts on our marketing campaigns or what's going on. You can feed that data back to PDW to enrich our overall strategy and decision-making. And you'll see that PDW is really positioned as your center of heart for data warehousing. So when we talked about that scale, integrating with SSIS, having the bulk load capability, we really see all of your structured data sources going directly into the PDW system. And this is through your typical ETL tools like SSIS, Informatica, and others. Finally, you have your direct reporting against the PDW system. This can be through reporting services or other tools. We have analysis server or SQL Server analysis services, and we can use that server to point directly to PDW. You can do rollup or direct query for the more real-time aspects of analytic reporting, but you also have the same capabilities to quickly create some of the performance structures and analysis services to do your reporting. And finally, we talked about the integration, so you have link tables from SQL Server data marts in your organization, and we can also use PDW as a processing engine to bring in Hadoop data, bring in structured data, process it, and spit it out to different environments as your customers deem fit. Okay, with a few minutes left here, I want to give you guys a different idea or kind of approach on some of the big data use cases that we're seeing. And one of our customers is using Hadoop heavily today. They're using PDW heavily today, and I wanted to take you through a little step-by-step process on how they're using that. So this is a large manufacturing company. They create microprocessing chips, and they actually take in a lot of their structured data into PDW to run their business, but now they're looking at how can we further optimize our assembly line, optimize the different machines we have, delivering the products, and how do we make that better process. And so what we see in terms of this manufacturing customer using these different technologies is not necessarily around unstructured or structured and etc., because a lot of the machine-generated data they get is structured, but it's really around the value density of the data. So when we talk about the value density, we say, structured data, your traditional data sources, if you have a transaction with your customer, you know their name, you know how much the transaction was for, what product they bought. That one row of data has a lot of value, so it's a high value and it's very dense in terms of what value it gives you. When we talk about some of these big data sources, what we start to see is a low value density. So you have these machines generating terabytes of data per day, and if you take a row of that data, right, the sensors are firing off every second, every millisecond, whatever that number is, that one row by itself doesn't really have any value. And so it's not until you get a lot of that data and you aggregate it together till you start having value for it to answer business questions. And so we call that a low value density in terms of how that data is being used. So when you see these two areas, how we see our manufacturing customer using PDW today in Hadoop is they have all their structured sources, some flat files they get from third parties. This is generating gigabytes of data per day. That's going directly to PDW on a day and an hour refresh cycle. And PDW storing gigabytes and terabytes of data, and it's where you do your direct reporting, your real-time reporting. This is also coupled with your Microsoft BI tools, SQL Server, downstream data marts, reporting services, and analysis services. You see that a lot of that data coming from the factory and assembly lines, this is generating terabytes of data per day. And all of that data is, you know, somewhat valuable, but not until you process across it is it very, very valuable. And furthermore, it's pretty difficult to store terabytes of data in a relational data set. It's not economically feasible. And so we see Hadoop or HD Insight as the data lake for taking in those terabytes of data per day, at times storing petabytes of data, and really exposing that data to our more specialized analysts to see how do we find the value out of this low value density data. You know, where's the actual signals, where's the value in that data set? And we use tools like Pig, R, and machine learning to find those value sets. Once we do, the manufacturers are going to use Polybase to expose that data to the business users, because once you find the different signals that actually mean something in those large data sets, you expose it to the PDW system for the interactive nature of the relational system. They're going to join it versus the structured data. They're going to ask interactive business questions of it. And PDW is a schema on write system, right? It's a system that's optimized for relational processing, so it knows how to take those user queries and structure data and process it effectively. Okay, and with that, I will end the presentation for any questions. So you got an overview of PDW, how it works, and how it's used in the industry.
Okay, thank you very much, Sean. Please, if you have any questions, right now you can type them on the question section. We got one question, okay? So I can read it for you, but you can also see it on the question screen. Can you please explain with a specific example, like what happens when the user issues insert statement, one row to be inserted? So what goes into those 80 distribution fact sales tables? Is it like one row of data is split into distributions?
It's a great question. So the lowest granularity is a row. Okay, so if we talk about you inserting a single row, that single row will come in, and based on the value of the distribution key, that single row will go into one of these distributions. So that whole row will go into one of these distributions. Okay?
Okay, perfect. We got other questions now coming. Let's see. How different is the T-SQL query that we get to use in PDW?
Mm-hmm. How different than, that was just a question, how different is the T-SQL query?
That's how it is spelled. How different is the T-SQL query that we get to use in PDW? I guess comparing SQL in PDW to SQL in SQL Server. Yeah.
Sure. So, you know, in fact, we're actually running SQL Server instances under the covers at SQL Server 2012 today. What's going to happen, so the T-SQL query is the same. What we've done is we haven't exposed all of the capabilities yet, because if you think of some of the capabilities like UDFs, we have to actually look at how we can run that efficiently in a parallel architecture. So the structure of the T-SQL is the same, the semantics are the same, but we haven't exposed all of the features like UDFs. And another thing you'll see is we actually made decisions on some other components we didn't want to expose, like triggers, for example. We saw that they don't perform effectively in quite frankly shouldn't be used in this type of architecture. So some of the ones that didn't make too much sense bringing over the PDW, we haven't turned them on. But they still exist in the code base, obviously, because we're running off a SQL server. But the T-SQL is the same in terms of what is there.
Okay, we have excellent conference. Thank you. One question is, where can I find more samples about Stream Insight storing data into PDW or SQL Server?
Well, I'm sure I won't tell you just go to Bing and search it, but I'm sure there's a lot of case studies if you go across that using, especially if you look at Stream Insight and sentiment analysis. Essentially, Stream Insight acts as a filter, so you can point Stream Insight to either SQL Server or PDW, and Stream Insight will essentially take in data. If you're familiar with Twitter, there's the Twitter Fire Hose. It's an API you can access that streams data. And Stream Insight will basically feed that Twitter data through it. It'll make decisions based on the filters that you set up, and then it'll forward that data somewhere. So it can forward it to a database like SQL Server. It can forward it to a database like PDW, and that'll just generally get stored inside of a table. So I would recommend maybe looking up, doing a search on Stream Insight and sentiment analysis for social media data, and you should find some use cases around that.
Great, thank you. We got a question here. What did the presentation mean by certified with Cloudera Hortonworks? Does that just mean that the Hadoop part of PDW is a well-supported build of Hadoop?
Yeah, so what it means is, we're partnering with the different Hadoop distributions. In this case, Cloudera and Hortonworks. What it means certified is we've taken their distribution running on Linux. We've taken for Hortonworks example, they have a distribution running on Windows, and we also have HD Insight. And we've taken those and we've run all the T-SQL query service area tests against it to determine that it's certified with the platform. So all of the queries will work. It also means that we support the different products, right? So if you're running Cloudera on Linux and you're using PDW with Polybase to use the T-SQL engine to go after that data, all of the components that we say are features that work should work. If there's any issues, we would support those. So that's essentially what certified means as part of the product family.
Okay, cool. Okay, we got a couple more questions. Can I create clustered primary key for any primary foreign key relations?
Okay, so there's a couple questions there. So primary key, foreign key relations, that's again around relational integrity. So one of the things you'll see is that we don't have strict relational integrity within the PDW system. We don't enforce relational integrity like foreign keys, for example. I want to be clear that primary keys and foreign keys are a little bit different than the distribution key. Remember, distribution key is more of construct used to lay out the data from a physical aspect. But what we typically see for our data warehousing customers is they will build that logic, the foreign key relational logic that they need within the ETL processes.
Great. Does PDW support schemas? If not, what is best practice for migrating from a schema-based architecture?
Sure. So what we've generally done in that case, we do not support schemas today. It's on our roadmap to support schemas, but what we typically see within the PDW system is that we distribute the logical differences or the logical constructs across schemas across databases.
Backup strategy. Is there any for PDW?
Yeah, there's many. Actually, so there's different ways to do that, and when we talk about your backup strategy, it really depends on what your requirements are. There's a couple of ways to do it, right? So you have your typical backup mechanism. You can run a backup command on PDW. You point it to basically a file server, right? You give it a location or a URI, and it will send a backup file there. We also support differential backups, and you have that option to take differential backups. You can take your full in the week and take differentials each day. So that's one strategy. If you kind of look at this architecture, it's very interesting in that we have this tight integration with Hadoop now, right? So what we're starting to see is some of our customers are using Polybase as part of their backup strategy because, you know, one of the things I didn't talk about is you can write a query that's using Polybase to pull data in from Hadoop, but you can actually write a query that pushes data from PDW out to Hadoop as well. And so what we're starting to see now is some customers have strategies where they're just, you know, pushing data out to Hadoop, and they might have some other, you know, mechanisms. They might have a Hadoop cluster that's geographically separate. They can push it out to that system as well from a backup strategy perspective.
Okay. Will PDW be available on the cloud?
That's a great question. So if you certainly look at Microsoft, we are moving to put everything on the cloud. If you ask me, right, that's one of our main strategies within the Microsoft Corporation. So I can't tell you when or where, but it's definitely something that we're looking at very strongly and something that we're taking very seriously to deploy PDW, but it's not there yet.
Thank you. Is it possible to get a copy of the PowerPoint? Yes, it will be on the Big Data Virtual chapter website in about 2 days. Okay. Another question is, what changes are expected in PDW when SQL 2014 ships?
That is a great question. So it's very interesting how the two engineering relationships work. So you have an engineering team specifically for SQL Server. You have an engineering team that's an extension of that that's specifically for PDW engineering. And what we see is kind of a little bit of a leapfrog. So SQL Server 2012 came out. We took SQL Server 2012. We actually innovated on top of that. We were the first ones to deliver updatable cluster column store indexes, which is a feature you're now seeing in SQL 2014. So what essentially happens is you know, we take whatever release of SQL 2012 is coming out based on our release cycle. We take that, we extend whatever innovations we have to the parallel framework, and then we release it within the PDW footprint. And what we've seen historically is then the SQL Server engineering group takes that and brings it into their version for their next release. So there isn't a kind of a strict roadmap that's matching or aligning the two, but we do have complete integration between the two. So all the SQL Server 2014 tools, they're going to be compatible with PDW. And so if you kind of looked at that roadmap, we're on a little bit of a different roadmap. We're delivering, you know, more feature sets more quickly in the platform than you would see the other Microsoft tools.
Okay, and then I think is the last one. Can you use common table expressions in PDW? If not, is there a best workaround? Well,
we've implemented portions of CTEs within PDW. We don't have the full components of it just yet. It's actually in our roadmap. It's scheduled to come hopefully later this year, I believe. But it really depends what you're doing if you want to look at what the workarounds are. It's really dependent on what you're doing. If it's going to certain type of logic going within a stored procedure, it depends what that looks like and the steps are.
And now we got a really nice question from Miguel. How can I set up an environment with PDW without buying the appliance for dev purposes?
Yeah, you know, unfortunately, that's one of the options we don't offer today, right? We don't have PDW outside of the appliance. It's not a software solution. It's an appliance, and so that means it's tightly integrated together. What we typically have is if there's customers that are looking at PDW, then we can definitely, I mean, whoever asked that question, they can email me directly. We can look at what you're doing. We definitely have systems in our labs that we can work with you and look at what those different workloads you're interested in running on PDW are. But we don't have a solution that you can run just software on your own systems, unfortunately.
Okay, I think that's everything. Thank you very much. We got a lot of questions. That was good. Thank you very much, Son Mikha, for being here today, and for all of you, all the attendees. This is Paco. Thank you. So this is Paco Gonzalez. We don't have right now a date for our next session, but we will publish it during this week on the website. Well, thank you very much all for coming. Have a nice night. Bye.